Hello student, in this video lecture I am going to explain the hypergeometric distribution. First we see the probability mass function of hypergeometric distribution. We have seen that the binomial distribution is applied whenever we draw a random sample with replacement. This is because in a random sample with replacement, probability of success P remains same at every draw. Also, the number of successive draws remain independent. Therefore, the assumptions of binomial experiments are satisfied. Now, consider the following situation. Here, a bag contains 9 balls. A bag contains 9 balls. Out of these 9 balls, 4 are red balls. 4 red balls and remaining are black balls. That is 5 are black balls. Okay, then suppose a sample of 3 balls is drawn from the bag and we are interested in number of red balls drawn. Then at the first draw, the probability of getting red ball is 4/9. Okay, then the probability of getting red ball at the second draw would be 3/8. Thus, this probability of success does not remains constant and the number of draws are not independent. Thus, the probability of getting red ball at second draw is depend upon the which ball we have drawn at the first draw. Thus, the sampling without replacement, in this case we cannot apply binomial distribution. In these situations, hypergeometric distribution is used. Now again consider the situation. Suppose a bag contains capital N balls. A bag contains capital N balls. Out of these N balls, there are M red balls. Out of these N balls, there are M red balls and remaining capital N minus capital M are black balls. Okay, means a bag contains capital N balls, out of which M are reds and capital N minus M are black balls. Now, a random sample of size N is drawn without replacement from these N balls. Okay, that is small n is equal to random sample. Small n is the random sample drawn from the capital N balls by without replacement method. Then suppose x is equal to, or let x be the number of red balls in a sample of size n. In a sample of size n. Okay, this is the x is the random variable. This random variable is the number of red balls in a sample of size n. Thus the possible values of this random variable x are this text values 0, 1, 2 up to n, assuming that here n is less than or equal to capital N. Okay, then the probability mass function of the random variable x is obtained in the following manner. Okay, then probability of x equal to small x. Okay, then if the sample contains n balls and this n balls containing the x red balls and remaining are n minus x balls are the black balls, then this x red balls can be selected from the capital M red balls in MCX ways, and the remaining n minus x balls, these n minus x balls are the black balls, these n minus x balls can be selected from the capital N minus M balls in capital N minus M C n minus x weights. Okay, now in sample there are both red and black balls, thus the total number of weights in which both red and black balls occurs is MCX into capital N minus MC n minus x. Okay, now this is the number of weights in which both red and black balls can occur, and now in all there are n small n balls in a sample. Then the small n balls can be drawn from capital N balls in capital NC n ways. This is the number of ways of drawing small n balls from the capital N balls. Now, by using definition of probability of an event, we get probability of random variable x equal to small x, which is equal to mcx into capital N minus mc small n minus x upon capital NC n. Here x takes values 0, 1, 2 up to n, and this is the probability mass function of random variable x. Random variable x is what? The number of red balls in a sample of size n. Okay, and which is the probability mass function of hypergeometric distribution. Here assume that small n is less than or equal to m. Now we can write the probability mass function of hypergeometric distribution as probability of x equal to small x, which is equal to mcx into capital N minus mc n minus x upon capital N C n. Here x takes values 0, 1, 2, dash dash dash, minimum of n comma m and 0 otherwise. Now this random variable x follows hypergeometric distribution with parameters capital N, capital M and small n. So this can be written as random variable x follows hypergeometric distribution with parameters capital N, capital M and small n, and this is the probability mass function of hypergeometric distribution. In hypergeometric distribution, the population is divided into two mutually exclusive categories. Then the number of draws are dependent. In hypergeometric distribution, the number of draws are dependent. The probability of success changes from trial to trial, and number of trials are fixed in hypergeometric distribution. Under these conditions, hypergeometric distribution can be applied. Okay, now we see mean of hypergeometric distribution. How to obtain mean, or it is called as the expected value of the random variable x. Okay, now mean of hypergeometric distribution, mean, which is expected value of x is equal to mu1 dash is equal to summation of x into probability of x equal to small x summation over x. Now substitute here probability mass function of hypergeometric distribution, which is equal to summation of x into mcx into capital N minus capital MC n minus x upon capital N C n summation over x, x running from 0 to n. Now this can be written as, here capital N C small n, this is the constant term, take out of summation sign, which is equal to 1 upon capital N C small n into summation of x into mcx. This can be written as m factorial upon x factorial into m minus x factorial. Okay, and capital N minus MC small n minus x. Also this can be written as capital N minus m factorial. Okay, now we keep this term as it is, capital N minus M C n minus x, here summation over x. Now which is equal to cancel the x, we convert x factorial into x minus 1 factorial, and m factorial can be converted into m minus 1 factorial as follows: 1 upon capital N C small n into summation of x into m into in bracket m minus 1 factorial upon this x factorial can be written as x into in bracket x minus 1 factorial into in bracket m minus x factorial into capital N minus m c small n minus x. Here summation over x running from 1 to n. Now here x gets cancelled. Now m is the constant, again take out of summation sign, then write down the remaining term. Then expected value of x is equal to m upon ncn into summation of m minus 1 factorial upon x minus 1 factorial into m minus x factorial. This can be written as m minus 1 c x minus 1 and capital N minus m c n minus x summation over x running from 1 to n. Now here we make some adjustment. We subtract 1 and add 1 here. We subtract 1 and add 1 in capital N minus m. Also we subtract 1 and add 1 in n minus x. Now this can be written as capital M upon capital N c n into summation of m minus 1 c x minus 1. This can be written as capital N minus 1 minus in bracket m minus 1 c n minus 1 minus in bracket x minus 1. Okay, summation over x running from 1 to n. Now the value of this summation is equal to capital N minus 1 c small n minus 1. Okay, now this becomes capital M c capital M upon capital N c n into capital N minus 1 c small n minus 1. This is the value of this summation. Now we simplify this. This is expected value of random variable x and which is equal to expectation of x is equal to m upon this ncn can be written as n factorial upon small n factorial into in bracket capital N minus small n factorial. Now this also can be written as here n minus 1 factorial upon small n minus 1 factorial into capital N minus 1 minus small n plus 1 factorial. Here minus 1 plus 1 gets cancelled. Then write down remaining term in next step, which is equal to expected value of x is equal to expectation of x is equal to m upon n capital N factorial into capital N minus 1 factorial. Now this term small n factorial into in bracket capital N minus small n factorial, this term goes to the numerator. Now this can be written as n factorial into in bracket capital N minus small n factorial, this divided by n factorial into n minus 1 factorial into in bracket capital N minus small n factorial. Now these two terms gets cancelled. Okay, then here this small n factorial can be written as n into n minus 1 factorial, and this capital N factorial also can be written as capital N into capital N minus 1 factorial. Then we have m into capital N minus 1 factorial, this is as it is, and this n factorial can be written as n into in bracket n minus 1 factorial, this divided by this capital N factorial can be written as n into in bracket capital N minus 1 factorial, and this small n minus 1 factorial as it is. Now small n minus 1 factorial and small n minus 1 factorial gets cancelled. Again capital N minus 1 factorial, capital N minus 1 factorial gets cancelled. We have only capital M into small n divided by capital N. This is the mean of hypergeometric distribution. Expected value of x is equal to capital M into small n divided by capital N. Average of hypergeometric distribution or random variable x. Okay, thank you.